Good morning. Today we are going to discuss about this transmission line and radio frequency. Before that, we have to know what is transmission line. Transmission line is nothing but transferring electrical energy from one place to another place, or otherwise we can say transmission line is a conductive method of guiding electrical signal from one end to another end. We have some 5 types of transmission lines, that is parallel lines, twisted parallel cable, flat ribbon cable, coaxial cable, and strip lines. And in the transmission lines we have primary constant and secondary constants. Primary constants are resistor, capacitor, inductor, and conductor. These 4 are the primary constant of the transmission line. For resistance, the unit is ohms per unit length, and inductance is Henry per unit length. Conductance is ohm per unit length. Conductance is mho per unit length, and capacitance is farad per unit length. And this is the equivalent circuit. This is the equivalent circuit. See, resistance and inductance, conductance. This is conductance and this is capacitance. These look like for this T section. And these R, L, G, C, these 4 are the primary constant. These primary constants are uniformly distributed over the transmission line. The transmission line we called for this uniformly transmission line. And these are the secondary constants: characteristic impedance, propagation constant, wavelength, phase velocity. And these are the secondary constants. For characteristic impedance, Z0, that is square root of Z by Y. Z is impedance and Y is the admittance. For Z, we can write for R plus J omega L, and admittance Y is G plus J omega C. And propagation constant gamma, that is equal to square root of Zy. We know this impedance and admittance, so R plus J omega L into G plus J omega C. So alpha, propagation constant gamma, also we can write for alpha plus J beta. Alpha is phase constant, alpha is attenuation constant, and beta is phase constant. And next, for this wavelength lambda we can write for this C by F. C is constant, that value is C equal to 3 into 10 power 8, and F is for the frequency. For wavelength also we can write 2 pi by beta, that beta is phase constant. And phase velocity Vp equal to, we can write lambda into F or omega by beta. For finding this primary constant to secondary constants, we know the primary constant impedance Z equal to R plus J omega L, that we can write gamma into Z0. Likewise, G plus J omega C, that we can write for gamma divided by Z0. How it comes? See here, Z0 equal to, we know this characteristic impedance Z0 equal to square root of Z by Y, that we can write R plus J omega L divided by G plus J omega C. We are multiplying and dividing by this R plus J omega L. Here we can get R plus J omega L whole square divided by R plus J omega L into G plus J omega C. This square and this square get cancelled. So we can get R plus J omega L divided by square root of R plus J omega L into G plus J omega C. This we know this is gamma. See here, gamma equal to square root of R plus J omega L into G plus J omega C. So instead of this, we can write for this gamma. So R plus J omega L equal to, this gamma comes here, so Z0 into gamma. See here. Next, we are going to discuss about this for general solution of the transmission line. This is the equivalent circuit of the transmission lines. This is sending end voltage, this is sending end current, and this is voltage and this is current, and this is this impedance, and this is the length. This is resistance, and this is for impedance, and this is admittance. This looks like for this T section. The primary constants are distributed over the uniformly distributed over the along the lines. It may be either T section or pi sections. Okay. See, already we know this. R is series resistance, and L is series inductance, and G is shunt conductance, and C is shunt capacitance, and L is the total length of the transmission line, and S indicates for this distance from load to the point of observation, and DS is small section of transmission line, and Z is the series impedance, and Y is the series admittance. And ES is source voltage, and IIS is source current. Okay, ZDS is impedance of the small section, this is admittance of the small section. Now consider for this small section of DS having this series impedance ZDS, and let's current flowing through this section. The voltage drop across this section we can write DE equal to I into ZDS. That's we can write for DE, this DS comes here, so DE divided by DS equal to I into Z. This is equation number 1. Similarly, we can current for this, similarly we can write the current drop across the section DI equal to E into Y into DS. So, dI by ds equal to E into Y. That is equation number 2. Differentiating this equation 1 and 2 with respect to S. If you are differentiating d squared E divided by ds squared plus di divided by ds into Z. Already we know this di by ds equal to E. So, we can write d squared E divided by ds squared equal to E into YZ. This is equation number 3. Similarly, we can write for this current d squared I divided by ds squared equal to I into YZ. That is equation number 4. In these equation 3 and 4 are the differential equation of transmission line. In that differential equation, we have to write the solution. See, d by ds is we consider as m, and m squared equal to E into YZ. So, m squared equal to Y into this E and E get cancelled. So, YZ. So, if m equal to plus or minus square root of YZ. Likewise, we are writing for this m. So, the solution of this differential equation we can write E equal to A into E power root of EZYS plus B into E power minus root of EZYS, because here we are getting the m value is plus or minus root of YZ. So, we are writing E equal to A into E power root of EZY into S plus B into E power minus root of EZYS. This is equation number 6a. And similarly, we can write for this I equal to C into E power root of EZYS plus D into E power minus root of EZYS. This is equation number 6b. The voltage and current at the receiving end we can write I equal to IR. This R indicates for this receiving end, and E equal to ER. And also we have to substitute for S equal to 0. These values substitute in equation 6a and 6b. If you are substituting, you will get ER equal to A plus B in A plus B and IR equal to C plus D, because for S you are substituting 0, this comes 0, so E power 0 value is 1. So, we are writing A. Likewise, B, C, D. Okay, this is equation number 7a and 7b. Now, differentiate the equation 6a and 6b. Again, we have to differentiate the equation 6a and 6b with respect to S. If you are differentiating dE by ds, A, if you are differentiating e power x, you will get e power x only. If you are differentiating e power 2x, you will get 2 into e power 2x. So, likewise, you have to differentiate that e power root of EZYS first root of zy s into e power root of zy s minus, similarly you have to differentiate this b into differentiating this e power z minus into root of zy e power minus into root of zy into s. Similarly, for already we know this de divided by ds is iz. So iz, instead of this you can write for this iz. So a into e power root of zy e power root of zy s minus b into root of zy into e power minus root of zy s. We want only this current I. So I equal to this z comes here. So a into root of y z divided by z. Here that z we can write for root of z into root of z. That root of z get cancelled. So we can get for this root of y by z. So a into root of y by z into e power root of zy into s minus b into root of y by z into e power minus root of zy s. Similarly, we can write for this voltage E equal to C into root of zy into e power root of zy s minus d into root of zy into e power minus root of zy s. This is equation 8a and 8b. Now the voltage and current at the receiving end is, you can put I equal to IR, E equal to ER and S equal to 0 in equation number 8a and 8b. If you are substituting here, you will substitute 0, that is e power 0 is 1. So you can get IR equal to A into root of y by z minus b into root of y by z. This e power 0 is 1. So similarly we can write for this ER equal to C into root of zy minus d into root of zy. This is 9a and 9b. To find the arbitrary constants value a, b, c, d, from that solution of differential equation we introduced the arbitrary functions a, b, c, d. That a, b, c, d value we have to find. How we are finding this arbitrary constant values means by solving equations 7a, 7b and 9a, 9b. If we are solving these four equations, we can get the arbitrary constant values a, b, c and d. So we are taking for equation 7a and 9a. So 7a is ER equal to a plus b and 9a, equation number 9a is root of zy IR into IR equal to a minus b. If you are adding these two equations, this b is cancelled and ER plus root of zy into IR equal to a into a 2a. So 2a, we need only this a value. So a equal to ER divided by 2 in plus root of z by y into IR divided by 2. So already we know this root of zy. Root of zy, we know this characteristic impedance z0. So instead of that root of zy, you substitute z0. So a equal to ER divided by 2 plus z0 into ER divided by 2 into zr. So we can write a equal to ER divided by 2. Take outside, so we can get 1 plus zr, z0 divided by zr. This is equation number 10a. For IR, we can write ER divided by zr. So similarly, we can write B equal to ER divided by 2 into 1 minus z0 divided by zr. That is equation number 10b. And C also we can write IR divided by 2 1 plus zr divided by z0 into zr divided by z0. That is equation number 10c. Similarly, we can write for D equal to IR divided by 2 into 1 minus zr divided by z0. That is equation number 10d. If you are substituting the equations 10a and 10D in equation number 6a, that is a, b, c, d value in the solution of differential equation. Substitute that arbitrary values. You can get for this voltage and current equations. E equal to ER divided by 2, 1 plus Z0 divided by ZR into e power root of ZY into S plus ER divided by 2 into 1 minus Z0 divided by ZR into e power minus root of ZY into S. So, we are taking this 1 plus ZR ER divided by 2 into 1 plus Z0 divided by ZR. We can get e power root of ZY into S plus 1 minus Z0 divided by ZR divided by 1 plus Z0 divided by ZR into e power minus root of ZYS. If you are cross multiplying this ZR, you can get ZR minus Z0 divided by ZR divided by ZR plus Z0 divided by ZR. This ZR and ZR get cancelled. So, we can get ER divided by 2 into ZR plus Z0 divided by ZR into e power root of ZY into S plus ZR minus Z0 divided by ZR plus Z0 into e power minus root of ZY into S. This we can write for this K because this K is reflection coefficient. So, reflection coefficient is ZR minus Z0 divided by ZR plus Z0. Similarly, we can write for this current I equal to IR divided by 2 into ZR plus Z0 divided by Z0 into e power root of ZY into S minus K into e power minus root of ZY. Yes, these two equations is the general solution of the transmission line voltage and current equation. Thank you. Equation 11A can also solved by using this E equal to ER divided by 2 into 1 plus Z0 divided by ZR into e power root of ZY into S plus ER divided by 2 into 1 minus Z0 divided by ZR into e power minus root of ZYS. So, this is 11A. By solving this 11A, instead of that ER divided by ZR, we can write for IR. So, ER divided by 2 into e power root of ZYS plus e power root of ZYS. By solving equation 11A, this is the 11A, E equal to ER divided by 2 into 1 plus Z0 divided by ZR into e power root of ZYS plus ER divided by 2 into 1 minus Z0 divided by ZR into e power minus root of ZYS into S. Okay, instead of that ER divided by ZR, we can write for IR. So, ER divided by 2 into e power root of ZYS and IR divided by IR into Z0 divided by 2 into e power root of ZY into S plus ER divided by 2 into e power minus root of ZYS. Here see this ER divided by 2 and ER divided by 2. So, this is e power root of ZYS and e power minus root of ZYS. From these two we can take ER divided by 2 as outside. So, we get e power root of ZYS plus e power minus root of ZYS plus likewise take this IR Z0 divided by 2, we can get e power root of ZY plus S minus e power minus root of ZY S. So, ER this 2 goes here. So, e power root of ZYS plus e power minus root of ZYS divided by 2 plus IR divided by Z0, same thing e power root of ZYS minus e power minus root of ZYS divided by 2. This looks like one formula, that is cos h equal to e power theta plus e power minus theta divided by 2. So, that we are writing here. So, E equal to ER into, instead of this we write for cos h theta, the theta is root of ZY into S plus IR divided by Z0. Likewise, for sin h, the formula is e power theta minus e power minus theta divided by 2. So, sin h root of ZY S. Similarly, we can write for I equal to IR cos h root of ZYS plus ER divided by Z0 into sin h root of ZS. Finally, these two equation is the general solution of transmission line. We can write that formula also, this formula also. These final E and I is the voltage and current equation of the transmission line. Thank you.